Hello everyone, I'm Nikita Dvornik, and today I will present our work, StepFormer, Self-supervised step discovery and localization in instructional videos. To start, let us clearly define the problem. Given a long instructional video, the task of step discovery and localization involves discovering the instruction steps in the video and localizing them in time. While this task is useful for many practical applications, annotating the video data is laborious and time-consuming. Thus, in this work, we propose to take an unsupervised approach to this problem. To this end, we propose StepFormer, a two-stage pipeline for step detection and localization that requires no human supervision. Thanks to its scalable design, StepFormer can be trained on a massive unlabeled video dataset. It achieves state-of-the-art results, outperforming even weakly supervised methods. Let us now consider how it's done in more details. As mentioned earlier, annotating instructional video datasets with instruction steps and their start and end time is laborious and does not scale to large datasets. In this work, we embrace this challenge and tackle the problem without supervision at all. To solve the task without supervision, we leverage How200M, a large-scale dataset of instructional videos. This dataset consists of YouTube videos where people perform different procedures. A critical observation here is that people tend to verbally describe their actions when they perform the procedure. This means we can use automatic speech recognition, ASR, to get a noisy text sequence that roughly corresponds to the instruction steps in the video. We then can use the sequence of phrases as language-based noisy supervision. More precisely, to get from the audio stream to a sequence of meaningful phrases, we use YouTube's ASR and get subtitles from the video. Then run a number of NLP tools to do coreference resolution and punctuation reconstruction, and finally transform the subtitles into a sequence of verb phrases by running even more NLP tools. After that, we embed the obtained phrases with a pre-trained language model, UniVL, to get a sequence of phrase embeddings. On the video side, we extract a sequence of clip representations with a pre-trained video model, also UniVL, and apply our StepFormer on top of that. StepFormer is a transformer decoder that attends to the video and outputs temporally ordered sequence of step slots. Importantly, the video and language encoders we use here were pre-trained jointly to map video and text into the same space. Thus, right from the beginning, we expect the step slots to somewhat align with the step phrases. Now, the question is, how do we supervise the sequence of step slots with a sequence of phrase embeddings? To define the loss between the two sequences, we use DropDTW, a sequence-to-sequence alignment algorithm that puts the elements of two sequences in correspondence while ignoring outliers. Using DropDTW alignment, we find matching step slots and phrase embeddings and use these correspondences to compute contrastive loss. This supervision forces StepFormer to output ordered step slots with embeddings similar to those of the present phrases. Crucially, DropDTW's ability to drop outliers ensures that we avoid predicting irrelevant phrases in our step slots. During inference, StepFormer predicts a fixed number of step slots that's sufficient to cover a long procedure. Since the number of step slots is fixed, the model predicts an overcomplete set of step slots, some of which are inevitably useless or duplicated. To filter them out and ground the high-quality slots in the video, we use sequence-to-sequence alignment with DropDTW for step localization inference. More precisely, we temporally align the step slots with the video and effectively drop both the relevant slots and the video frames where no procedure steps happen. This essentially discovers video segments that contain different instruction steps. Now we compare our model to existing baselines on the task of unsupervised step discovery on three standard benchmark datasets. Our model is unique in multiple ways, as it is the first to make use of large unlabeled dataset and its ASR subtitles for supervision. As a result, it is the first model that does not rely on a fixed vocabulary of instruction steps, and thus learns generic procedure model that can be applied to any instructional video dataset. We show that StepFormer outperforms all weekly and unsupervised baselines on step discovery with zero-shot generalization, that is, never seeing the target dataset during training. And this is despite the fact that other models being trained and tested on the same dataset. Here is the qualitative picture of how our method discovers segments in a video. Clearly, our step segmentation is very close to the ground truth, while other methods struggle with this task. To summarize, in this work, we introduced StepFormer, a general-purpose procedure learning model. We train StepFormer with noisy subtitle supervision using DropDTW for alignment. The resulting model outperformed unsupervised and weakly supervised baselines with no adaptation to the target dataset. Thanks for your attention. If you're attending CVPR in person, come see our poster number 6865 in the Thursday AM session. Our code will be made available online.